Okay, so we start this lesson. This would be a very short lesson, and after finishing that, we can actually go. So I wanted to finalize this part that we have started before. If you remember, we started talking about the conjugates. So we defined the conjugate of a complex number here. We said that if I have the lesson as a start, sorry. The conjugate of a complex number z equals to a plus bi is denoted by z bar, and it is defined to be the same the complex number whose imaginary part is the opposite of the uh, imaginary part of the original number. And if you remember, we talked about this example. So for example, if I have this complex number, its conjugate becomes the complex number with the same real part, but its conjugate part, it becomes the opposite of the conjugate part. Okay, and I wrote here, it is good to remember that the conjugate of the imaginary unit is negative itself. Okay, and then if you remember, we had some theorems. I told you that I put them under the title of a theorem because I want you to know about them if you are interested to know more. But these are scattered through the problems in the book. So there are different problems in the book. They ask you to show these things. Okay, and this is why I'll solve that problem for you. And then we want to start another problem today. So that is also level 3 problem. For example, this one is a level 3 problem. This one, a level 3 problem in the book. So we want to prove the parts of this problem, and solve two more examples, and then we are done. Okay, so let me start with the simpler one. Yes. So here, z and w are given complex numbers. We want to show that if you add the complex numbers first to get a new complex number and then calculate the complex conjugate of that, it becomes equal if you do them separately. It means that take the conjugate of the first part, take the conjugate of the second part, and add the conjugates together. Then the answer that you will get would be exactly the same answer. Okay, so let us check why this is true. I don't think you will face any problem. So where would be the starting point, do you think? Yes, please. Pardon? You need to speak a little bit louder. Okay, how? You mean that you need to, because z and w, I want to interpret them as z plus w. So how should I do that? Yeah, exactly. Yes, that was my point. Yes, thank you. So you would say that for all parts, let us do for all parts this. So I would say let z be equal to a plus bi, and w be, for example, c plus di. Then we start different parts now. Number one. Okay, so let us start from the left-hand side of that. So this becomes equal to. How should I do that? Let me write everything. Z plus W bar. So this means that instead of Z, I can write A plus BI. And instead of W, I can write C plus DI. And then I have a bar on all of it. Okay, so that is the meaning of the left-hand side. And now what I have to do, I have to add these two complex numbers, but we already know how to add them. Yes, I have to add the real parts together, so it becomes a plus c. It becomes the real part of the sum. And then I have to add the imaginary part, so it becomes b plus di. Yes, and then I want to take the conjugate of the whole combination. So that is the meaning of the left-hand side. But now, can you tell me what is the conjugate of this expression here? Yes? Yeah, just say it.
A plus B minus B plus DI.
Yeah, a plus c minus b plus di. Yes, exactly. So that would be the same complex number, but you have to change the sign of the imaginary part, okay? So this becomes a plus c minus b plus di. But now I can distribute it again, so this becomes a plus c, and then I multiply that I and negative sign inside, it becomes minus bi minus di. And then I recollect them. This one I collect it with this one, and I will collect these two together. So then it becomes a minus bi, and then I will have plus c minus di. Now if I ask you what do you see here, it's clear, yes? This is z. What you see here is the same real part, but its imaginary part is negative of the imaginary part. So this is nothing except z bar, and this is nothing except w bar, yes? So then it becomes z bar plus w bar, and that is exactly equal to the right-hand side. Okay, so it doesn't matter if you add first and then conjugate, or conjugate first and then add. This is the meaning of this operation. And the same is true for subtraction, which is more or less the same thing, so I don't want to spend time on it. You can solve it yourself, but these are more tricky ones, okay? I don't think the book has mentioned this, but I saw that this was in the book. It was a national test problem. So we want to do that one together. But number 4, you can solve it yourself, and I really recommend you to do it at home as an additional exercise. Okay, but what do you think about number 3? What should I do? What would be the strategy? Number 3. Yes?
We would use the same strategy.
Exactly. That was my point. Yes, exactly. Strategy, calculate these things to see if they are the same or not. If the algebra becomes complicated, what we can do, we can calculate the left-hand side, we can calculate the right-hand side and compare them. Okay, I don't know. Let us see how this will go. Can we start from the left-hand side and right to the right? Let me do it 2 different ways. So let me start number 3. Let me calculate apart the left-hand side. So I would say the left-hand side is equal to, it is z dot w then bar. So, but you know that z is a plus bi, and w is c plus di. So be careful here. You see the bar is on all of them. So it means that the priority is with this product operation, multiplication operation, and then you have this operation. So, but you know how to do that, yes? We need to simply multiply these like polynomials. So it becomes ac plus a di, and then it becomes bci, and then I will have bdi squared, yes? And then I have a bar on all of it. But immediately you realize that I squared is nothing except minus 1. So what I do, I write it as minus bd and collect it with ac, because they don't have i's, so it means that is the real part. So what we do, we continue like this, so it becomes ac minus bd as the real part, and I factor an I out between these two terms. So what happens, it becomes AD plus BC multiplied by I, and then don't forget that we have a conjugate on all of it. But now if I ask you how do you calculate the conjugate of this expression, you would say that I will keep the real part as it is, but I will change the sign of the imaginary part, yes? So then it becomes what? It becomes AC minus BD, and then I will have minus AD plus BCI. So this is, let me call it number 1, yes? So this is the left-hand side. Now we calculate the right-hand side to see if that is also the case. But for the right-hand side, you see that I have to calculate z bar and w bar first. So I have to calculate z bar, w bar. If I ask you what is z bar, it is easy. It is a minus bi, and then I multiply it by c minus di. So let us calculate this. So it becomes AC minus ADI, and then minus BCI. Then it becomes positive BDI squared. But for the same reason I squared is minus 1, I can write AC and minus BD as the real part, and I can factor a minus sign and I out from these two terms. Yes, this term and that term. I am pulling minus sign out, so both of them will be positive. I am also pulling I out. But hopefully you agree with me that these two are exactly the same. So if now comparing 1 and 2, you can conclude that the left-hand side is indeed equal to the right-hand side. Yeah, is that understandable? So I really, because I told you that if you want to go to mathematics, physics, or electrical engineering, anything, complex numbers are very important. So try to learn them by heart. So these are the properties of the conjugates. Okay, now before going further, what would be your opinion about this and why? If I have z to power n and if I want to conjugate it, what do you think I can write in front? N is a natural number for the time being. So I have a complex number, I multiply it by itself 3 times, 5 times, it becomes a complex number, then I take the conjugate of the result. How do you think it will relate itself to the conjugate of z?
I would say it's conjugate of z to the power of n.
Can you elaborate more? That's
Because
correct.
of the third.
Yeah, exactly. Because, for example, if I tell you z3 to so let me write z2 bar, it means that z times z bar. But we learned that this becomes z bar times z bar, but z bar times z bar is z bar to the power of 2. Yes? And the same story happens. But do you think this also is valid for negative integers? Because you remember, by the time we have learned z to power 0, which is defined to be 1, we learned z to power natural numbers, we learned z to power negative integers. But we haven't talked about z to power 1/2 yet. Okay, so that's a little bit technical, we will learn that later. Okay, but can you tell me what will happen for z to power minus 2? Do you think the same story will work here? If I have a negative number. So let us check. For example, if I want to calculate z, let me write and then I will clean it. Okay. So if I want to calculate z to power minus 2 bar, what is the meaning of this? What is the meaning of z to power minus 2? It means 1 over z to power positive 2, and then I have to put a bar on top of that. Yes, I haven't shown the last one for you, but I told you that this is also true. So if you have a fraction and you want to take a bar, you can take the bar of the numerator and the denominator separately. So what you can do, you can write 1 bar divided by z2 bar. Yes? But what is 1 bar? It's 1, yes? So 1 bar is 1, and then we just showed that z2 bar is equal to z bar 2. And then I bring it up again, so it becomes z bar to the power of minus 2. So this also works for negative numbers. Is that understandable? So with what we want to show, actually I wanted you to know is that let n be an integer. So you see I haven't mentioned positive integer or negative integer. It can be any of them. And then we have this simple formula. Z bar to the n equals to z bar, zn bar is equal z bar n. Okay, but something that I want you to remind you about that. Do you remember last time we learned about these are very important one, especially if you want to solve a little bit higher level problems. So we learned that if I add a number with its conjugate, it becomes 2 times the real part of that number. So this means that if I have this combination, I don't care what z is, the combination is always a real number. And if I have this combination, z minus z bar, z and z z can be any complex number that you like, but the difference of these two is always a pure imaginary number. At least if you don't remember them, remember these ideas. They could be very handy, especially if you want to solve harder problems. Okay, so I think I can wait a little bit for you so that you can solve these two problems to yourself. And after that, I will solve this and then we are done. Okay, for today. So let me just stop this video here. Okay, so do you have any opinion how to solve this problem? We want to show that this combination is real. Okay, that's a complex number to power 100. It contains 101 terms, 101 terms. We want to show that this, at the end of the day, will become a real number. But how this would be related to lesson today, at least you can recognize 2 plus 3i and 2 minus 3i. Yes, you want to answer?
I mean, can't you just infer that it will cancel out everything except whatever term is?
Okay, but that's what we want to show explicitly. Yes. Yes?
Okay, so to 2 plus 3i squared power 50.
Yes, I was thinking, I don't think it will work. We can try that idea. Yes, that's a good idea. So let us try. So you are saying that 2 plus 3i to power 100, that might be a good starting point to write 2 plus 3i to power 2 and then to power 50. And then, of course, we can calculate this. It becomes 4, 2 times the first one times the second one, 12i. And the second one to power 2 becomes 9i squared, but I squared is negative 1, so it becomes 9, minus 9. Yes? And then to power 50. You see, we have the same trouble, more or less. Of course, might be you can do it because 4 minus 9 becomes minus 5. Yes? And then I had 12i to power 50. Yes, might be this work if you are patient to do it continuously and then go to 25 and then I don't know, after 25 that's a dead end, yes, because then you have a fraction power. So this is different. You are comparing it rightly with this, correctly with this problem. Yes, that's good. Because in that problem, what was the reason that we were able to solve it by this method was because when you write it in this form, the answer of this part becomes 1 plus 2i plus I squared to the power of 50, but I squared is negative 1, and they cancel out, and what is left for me is just a monomial. And raising a monomial, a single term, is not hard. So this is why, even though, based on your previous experience, this might be a good starting point, but you see that this will not work. The reason it worked because coincidentally these two canceled out, which does not cancel out here. Okay, so this does not work, and I will go. So this is why I want to clean it up. But on the other hand, you know that I am giving you examples. So in principle, you have a guide now because you know that the lesson is about complex conjugates, and I am giving you an example. So this is a big hint, but in the exam, you don't have that hint. You need to discover this is related to the complex conjugate itself. Okay, yes?
We can use the theorem that the sum of a complex number with its conjugate becomes 2 times the real part of the.
And then that would be real. So what is left for you is to show that these are conjugate of each other. And so I need theorems, yes? So I would say exactly. So I would say let z be equal to 2 plus 3i to the power of 100. Then what can I write for z bar? Z bar is 2 plus 3i to the power of 100 and then bar. This is the meaning of z bar. But we just learned, how can I do that? I can flip this sign of bar after and putting it on top of this one. Yes, we just learned z n bar is z bar n. Yes, so what I can do, I can write it as 2 plus 3i bar and then to power 100. This is the previous remark. Yes, and now what is the bar of that expression? Everyone knows about that. So that is nothing except 2 minus 3i. And then I have also a power of 100. So therefore, the question mark, what you see here, instead of this expression, I called it z, and I realized the second part is nothing except z bar. So this question mark is actually z plus z bar, and we know that z plus z bar for any real number, it is 2 times the real part of z. Okay? And then this is real, which is a real number. Okay, is that understandable? So that is a real combination, but can I know about real z? No. If I ask you, can you give me the number for real of z? It's not easy at all, because if I want to calculate, I need to suffer and raise it to power 100 and collect them to see what that real part is. And this is why the problem doesn't ask you about the real number itself. It's just asking you to show that this is indeed a real number. Okay? Is that understandable? Yes or no? Okay. So you see, this is a trick that we can use. The other one is more tricky. Okay. I don't know. Do you want me to pause the video so that you can think a little bit for 5 minutes? Uh, yes, that is better. Uh, so I think you realize what I said. I think it's very easy. Might be you are tired. It's not that hard. So I told you that this is tricky. I agree. The first starting point might be a little bit tricky. Why should I do that? But then I don't think that what is left is hard. So I told you that if two complex numbers are the same, so definitely the conjugates are also the same. So this would be this one to power 5 conjugate is equal to c plus di conjugate. But you remember that I can flip this inside, yes? This is z n bar is z bar n. So what happens, this becomes a plus bi conjugate and then to power 5. On the right hand side, I can simply write c minus di. That's the meaning of conjugate. But then if I apply the conjugate on the left hand side, you will get this one. Yeah, we can keep the pair of brackets here. Okay, so this is something that I told you that you can do. But can you tell me now, is it hard to see you want to go from here to here? So, sorry, you want to get this one. Yes?
I multiply both sides by I.
By I, okay, that is a good idea. If you multiply both sides by I, you already fix this. So yes, that's it. So you see, it was not hard because you see that you have a negative sign, but your goal is to reach to a positive sign. So you say that I multiply this by I and I multiply this by I. This will fix the right hand side because this becomes ci minus di squared, but minus di squared is nothing except d, and then I have ci. So this will fix actually. You are completely right. But what is your way of dealing with the left hand side? Because that is I. What should I do? Do you understand what I mean? Because if you multiply I here, then what? Yes? Yes, so that is a better idea. So you see, this is the way that you need to learn problem solving. But actually, you are also right. What is I to the 5, by the way? Yes? It's I. Do you agree? Because I to the 5 is I to the 2 to the 2 and times I. But I to the 2 is minus 1. Minus 1 to the power of 2 is 1 times I. So there is no difference between I and I to the 5. So let us multiply by I5. This will serve your method, your problem as well. Yeah. So I multiply by I to the 5. So it becomes I to the 5 times A minus BI to the 5 is equal to I to the 5 times C minus DI. Yes? But now, what can I write for the left-hand side? I hope that you agree with me because I have two powers the same. I can use this rule. So I have z1 to power n times z2 to power n. I can write z1 times z2 to power n. I haven't mentioned this, but am I allowed to use this? Why? Am I allowed to use this rule? Even though if you go to my lessons, you see that I haven't talked about this rule. Am I allowed to use it? If yes, why?
Yes, because we can do it for real numbers.
Exactly. Because I told you that we have to keep all the rules of real numbers the same, we just want to add one new rule to that. Thank you. So then it means that I can do that. Then it implies that I have a times a minus bi, and then I write to the power of 5. But then I go here and calculate I5. I5 is I2 to the 2 times I. But this becomes minus 1 to the 2 times I, which is I. So this means that instead of this one, I can simply write I. Okay, so this becomes I times C minus DI. And then on the left-hand side, if I multiply I in, it becomes AI minus BI squared to the 5. And if I multiply I on the right, it becomes CI minus DI squared. And then we are done because I squared is nothing except -1. So this implies that I have B plus AI to the 5 is equal to D plus CI. So you see, some problems you need to be creative. This needs experience, okay? And that is the goal. In your studies, you need to reach to a level that you should be creative with what you are doing. Otherwise, that is a waste of time to study something and don't know what to do with that. Okay, no questions? Yeah, we will end this meeting here. Thank you very much. I will upload this on the YouTube.